We've been talking about the model-based enterprise for over 20 years. In the last 17 years that I've been involved in standards, we haven't made a lot of progress. The model-based enterprise is a very complex topic, requires a lot of technology and changes within the workforce across all layers of the manufacturing extended enterprise.
So the model-based enterprise is about going from top-down business all the way through engineering down to the manufacturing, centered around a model, a digital model where all the information relates directly to the model.
What was originally on 2D prints and human consumable is now in the 3D CAD model as machine consumable format.
So this is a major digital transformation looking at different aspects of our business to bring us from a 2D drawing or print specific focus to looking at our product designs in terms of models. And it's not just CAD geometry, it's different types of models. It's analytics models, it's quality models, it's planning models.
The digital thread is how you do the model-based enterprise, specifically through the interactions between all the different players within the enterprise and how the information flows consistently and relates to the model.
Model-based manufacturing has a lot of capabilities on being able to communicate in one concise format all of the information surrounding the expectations.
It's a paradigm shift from me having to do it manually to teaching my software the strategies that I normally would take given the feature type and the tolerance that that feature has to be made to. So I would say that, well, for a tight tolerance, have this strategy. For a loose tolerance, have that strategy. I can specify the tools to use, the type of machine it goes on. Since the software knows and I have my digital format, all I do is import, click a few buttons, and my program's generated automatically.
It's really great to see when you've had a backlog before and you don't really understand what is taking so long or what these issues are. Manually adjusting and manually calculating is completely different than when you actually see the true analytics, the data, and the software.
And we try to maintain that relationship all across the life cycle because when you manufacture things, obviously there will be variations. It never goes as precise as you want it to be, but we want to capture that variations and use that, tie that to the nominal geometry with the original intention. That's essentially what a model is.
All these interoperability, different types of models lead to cost in translation. We want to reduce the cost.
That translation can come with, especially as we're talking about CAD and PMI in whole model-based definition. You're talking about geometry translation problems and annotation translation problems.
Achieving standardization in the model-based world involves getting agreement on the constructs of what a model is in the first place and what various parts of the model in defining a certain aspect of geometry or metadata like nodes or material stuff.
The difference between standards and non-standards based is that many applications have what are called native forms, which are proprietary to the actual applications. And so the data is native to those native applications. Standards are supposed to be neutral, and they're a way to communicate data that is agnostic of the actual applications.
It's very important to maintain and to go by the standards. Why? Because there's a number of different software solutions that are out there.
We're all operating potentially in our own CAD platforms with different interpretations of how the model and the data should be presented. But with standards now, you provide interoperability to facilitate the reuse of that data, right? And that should drive the cost down of design and engineering for the life cycle of that plane.
The standards are well defined and have been around for many years. The problem is the implementation. Often the standards are misunderstood and the implementation doesn't provide exactly what the standard's intention is.
We think that the standard is this black and white thing there's lots of human beings involved and software applications and details. And so we have problems all the time in what we consider to be standard data that's not standard. So you get multiple people in this area and you get collisions, you get things that don't line up.
Work is needed to improve the implementation of these standards and provide information down to the various different parties in the supply chain to correctly utilize what we've already got. In this video series, we're going to be exploring this from many different viewpoints, both the primes, the SMEs, the middle tier, and how they're progressing on their digital journey. I hope this video series will foster communication between the different parties and help us proceed down the digital transformation journey for all parties.